Today we're completing our periodic trends lab. In part one, we're investigating the trends of some metals in water, how they react. So in both of these test tubes right here, I have just regular plain old water. Then in front of each test tube, I have magnesium and I have calcium. And we're going to investigate how they react in water. So up first, I'm going to grab my stick of magnesium and I'm going to drop it into the water, make sure it gets down in there. And as it gets down in there, we see a whole bunch of nothing is happening. It's just chilling out. And even if we take it out and give it a good old-fashioned swirl, nothing appears to be happening. So magnesium isn't reactive in water. But as we take a gander down the periodic table one level, we get to calcium directly below magnesium. And when I take my calcium and I add it to my water, we instantly notice that something is up. It starts to bubble and fizz, indicating that it is in fact reacting with the water. Now would be an excellent time to pause your video and record your observations on your data sheet and answer the question available to help you prepare. Come back when you are done. Moving on to part 2 of the lab, we are now investigating the reactivity of some metals, this time in hydrochloric acid. So I have 3 test tubes, each containing hydrochloric acid. Now we're going to review the reactivity of magnesium, zinc, and tin in our hydrochloric acid. So let's do magnesium again. Hopefully it's a little more exciting this time. So we drop in our magnesium and instantly things are a lot more exciting than last time. If you can notice, it is actually sitting on the surface. It is not getting underneath at all, but it is bubbling and fizzing, and there is even some steam coming out the top. It is quite the reaction happening with the magnesium this time. Now as we move over to the right on our periodic table, we can also do zinc in hydrochloric acid. So I drop the zinc in there, and we can see that it is lightly bubbling, but nothing near as exciting as what's happening over there with the magnesium, but it is still bubbling and definitely reacting in there, producing some of that steam that we saw before. It's a great reaction. Now, last but not least, we are going to take our tin and drop it in that hydrochloric acid. And much like the magnesium in our first trial, we see our zinc in our hydrochloric acid is not doing much at all. It is basically just hanging out there, showing us that it is the least reactive. So you can once again compare the 3 reactions with magnesium, zinc, and tin. Now would be an excellent time to pause your video to fill in your observations and answer some questions related to part 2 of the lab. Come back when you're done. Part 3 of our lab involves a trend that we really didn't talk about, and that is density. The density of elements also has a trend throughout the periodic table, and we are going to investigate the density of silicon in order to determine what the density of it is. So right now I have a piece of silicone in my hand right here. Up first, we are going to put it on our balance. So we have our balance. It right now says 0 grams. So when I put the silicone on there, we can see that we have 6.51 grams as our answer. When we move back, now we have to figure out the volume of our silicon, and the easiest way to do that is by using a graduated cylinder, just like we did in our previous units. So you can see that right now my water is right at 25 milliliters. So then when I add my zinc, it goes up all the way to, so we're at 25. That each one of these lines counts as 0.5. So we have 25.5, 26, 26.5, 27, 27.5, 28, and it looks like it is right at 28.50. 28.50 is our new volume. Based on that information, you should be able to calculate what the volume of the silicon was that I added to this graduated cylinder. Those are the 3 parts of the lab. Make sure you answer all of your questions in your Nearpod activity and use your lab sheet as a guide.